So this is just a back to the beginning on logs. You can make this into a log. Log base 5 of 26 equals x. And then that solved it for x, meaning x is alone, see? And there's the answer, which in this case is not very satisfying. If this had only been a 25, do you get the answer would have just been 2, right? So it's just a little tiny bit more than that because it's actually 26 right here. And so then it's 2.1 or something like that, 2.059, who knows? It's something tiny bit more than 1, or sorry, 2. All right. So here's what one of your questions is going to look like for today. Log base x of 4 equals 3. And they'll say, solve. And if you know how to rewrite these things, it's really a piece of cake. Circle of logs to the rescue. And it may not just instantly solve for x, but it gets it so it's like one step away. Did you get x to the third equals 4? That's a good start. But then how do you actually finish the deal? Put it to the 1/3. I'm so glad you didn't say multiply by 1/3. Put it to the 1/3 is correct. And now this is just x. And did I do the kind where it needs an absolute value and therefore 2 answers? No. Remember, if this had been even, then we would have had to put in an absolute value on the x like this, but this was not one of that kind, so it's just 4 to the 1/3, whatever that is. What if it was multiple choice and it had this answer? Is that the same thing? Yeah. That's the third root of 4. Okay. Now, why am I done? Because x is alone. That's the whole point of today, is get the x alone. All right. Do you remember how to combine logs together? To be able to solve for x in this case, you want to combine the logs. I gave you a bold statement. I said, just like if you can factor it, you should. If you can combine them, you should. Rohan, what do they combine to? Okay, log base 3. Surprisingly, if they both have a base 3, then it's log base 3. And do you remember at all what to do with the x and the 10? Multiply them. All right. And I'm just copying equals 7 from above, right? All right. Now that makes it so that you can do the circle of logs again. Now, just so you know, circle of logs is not an official word. But I like it, and I think you understand it. Because it tells you what to do, instead of just saying, you should turn it into an exponent problem. Circle of logs kind of reminds you of how to do that. Now, like I said, it doesn't always just give you the answer. Is x alone yet? No. Eric, what's the final step?
Divide by 10.
Correct. And nobody's going to expect you to know what 3 to the 7th is. So this one, you'd probably leave the answer just like that. 3 to the 7th is a ridiculously big number and way too big for a test. All right. What if the x is not there, but it's here? Can you solve that one? This time, when you're finished, I'm going to ask you to turn and show it to the kid next. weird because this is kind of patchy. There's so many kids missing. Please figure out a kid that's near you and see what they think this came out to be. I got it. All right. Did you get 8? Raise your hand if you had 8. Awesome. Now, I don't know if you have ever wondered what the graph of one of these would look like, but this is the time when you should probably start to wonder that. Take a second and just write that down. I made a bold claim in the past that you could graph pretty much anything as long as you made an XY chart. I said it was your best friend in graphing. Would you please make an XY chart? Think of some numbers for X. You get to pick. And then find me at least 3 points. If you can make like 4, it's way better. And try graphing this. I want to see if you can graph this without even me telling you how. Just from an XY chart and a few points. Once you get the idea where the dots are, you'll see the curve. And then hopefully you'll get the idea what they look like. I get it. This is stretching you right now. For some of you, this is beyond what you can do. If you can't think of anything else, try putting in X is 0 isn't even legal because you have to use a positive number there, right? Do you remember that? The base and the argument have to be positive. So what's a nice clean number to put in for X? 1 works. And if you put in a 1, this brings up a few of those patterns, and it makes me think, oh, I better review these with them, because if you don't know what this is like instantly, then you're kind of toast. I won the argument. Remember what I said you get if you win the argument? Nothing. 0. If there's a 1 in this spot, the answer is 0. Why? Well, look, if I want to write log base 3 of 1, and I don't know what that is, I can put equals x. And then you could say 3 to the x has to equal 1. 3 to the what has to equal 1? 3 to the 0 would equal 1, right? So I hope you just memorize that if there's ever a 1 right here, then there's a super easy answer. All right, so let's go through a few, and you got to be able to just like know these like the back of your hand. If I say log base 3 of 3, you should be able to go, I know that one. What is it? 1. Remember the deal where the answer will be the exponent on that, which is actually a 1? And if you're struggling to get why this works again, you say, I don't know what it equals. 3 to the x equals 3 to the 1. And look at that. That makes sense. X must be 1. All right. As soon as you know it, say it. 2. Because isn't this really like 4 squared? And therefore the answer is 2. Okay. Log base 3 of, careful, 1/3. Nice. This is like 3 to the negative 1, so it's negative 1. How about log base 5 of 125? 3. Because this is really 5 to the 3rd. Okay. How about log base 7 of, careful, negative 1/7? Why are you shaking your head? You can't do that. So what's the answer? There isn't any answer for that. There's no solution. That happens. All right, good. Now let's go back to that problem. I was just saying, let's get some points on this, and some of you were kind of stumped. So I just wanted to say, look, if you stick in a 1 right here, you're supposed to know that that equals 0. If you stick in a 3 right here, do you get how that'll work really nice? And then it's a 1. And if you stick in a 9 right here, do you get how that'll come out to 2? Does all that make sense to you so far? Then that's 3 points. I could have shown you the parent graph, but I could also just say graph these points. 1, 0, 3, 1, and 9, 2. But it would be informative to have the rest of the graph, Mr. Server. All right, it goes like this. And there's an asymptote right there. There is your classic log graph. That one right there, I'm going to label with log base 3 of x. Something you're going to learn in pre-calc is that there are functions that are called inverses of each other. This one's the exponential function. Do you remember that? Do you get how these are kind of like a reflection of each other a little bit? For some of you, this will make it snap into place. If you reflect it across that line, they are an exact reflection of each other. This one is the graph y equals 3 to the x, which is an exponential graph. This one is the log graph. Okay, so if I just said, here's my graph, would you know what generally this is? Is it an exponential or is it a log? It's a log. Now, to know exactly what it is, you'd have to have some points. But would you agree it's y equals log base something of x? I just don't know the base. And if the turn is really sharp, it's a big base, like 10. And if the turn is kind of slow, if it's more like a slow, lazy turn, then it's like a 2. So like, here's a slow, lazy turn versus the red one is kind of a medium versus this is an incredibly sharp turn. The green one, that's also a log, but it's like log base 12 of x. So the higher the base is, the sharper the turn is, that's all. Okay, so if I gave you a problem and said on the test, you have to graph this, y equals log base 4 of x, I hope you would go, well, I kind of know it looks like this, but I don't know exactly where it is, so I'm going to get some points on an xy chart. Let's do that. Would you please find me 3 points on this xy chart? I'm going to pause while you think up smart things to put in for x. That'll work nice. Then I'll give you a pro tip about what I always pick. Okay, here's my pro tip on which numbers I always pick. I always try to make this part be 0. You might be like, but that doesn't work. Yeah, but it gives me the asymptote. See how x is 0? X equals 0, that's like the y. Oh yeah, there's an asymptote here. Did you even remember to put in the asymptote? I bet a lot of you didn't. That's why I do it. Reminds me to put it in. The directions will say, must include asymptote. So hopefully you'll read the directions and you'll go, oh yeah, that's right, there's an asymptote there. Okay, then I always try to make this part be 1, because if you won the argument, you get 0. So 1 comma 0, that's right there. Then I always try to make this part match the base, like with a 4, because then when I put a 4 here, log base 4 of 4 is 1. Now, notice I'm not going to put in a 16. You might have, but do you get on the test there? You must never have a graph that has 16 spots. You're not going to be able to graph 16. It's too big. So pro tip. Did anybody put in 1/4? I'm just curious. Did anybody think of that? Nice. A bunch of you thought of that. Because, see, you can't do it with only 2 points. 2 points will give you a straight line. It won't give you a curve. Why are we putting 1/4 there? Watch. If I do log base 4 of 1/4, that one works nice because it's really 4 to the negative 1, so it's -1. Now I got 3 points. See those 3 points? That's enough with the asymptote to tell me that, oh yeah, it goes like this. Just 2 points, way harder. And not legal on the test. We're going to say 3 points, because to determine a curve, mathematically, 2 points does not determine a curve. 3 points can show you where a curve is. Okay, so you have to have 3 points in the asymptote. All right. Do they get easier? No, they get harder. So let's just do one more at this medium level and make sure you get this. Y equals log base 2 of x. Just find me 3 points and the asymptote. This time, don't even graph it. Just give me 3 points in the asymptote. I trust you all can graph points and connect the dots since you were a little kid. Brandon, tell me 1 point that would work. 1, 0 is one of them. Nice work. Zeke, give me a point that works. Sure. 0 is the asymptote. Nice work. All right. I'll take volunteers. I know these are kind of scary. It's the first one I've asked you to do by yourself. Who's got this? Another point. Yes. 4, 2. Yes, because you chose 4 on purpose because you knew it was 2 squared. So, yeah. And is that enough points? No, it's 2 points. This is an asymptote. So it's a kind of fake out. It looked like it was 3 points. It's only 2 points. So what's one more point? 2, 1. That's enough points. Yay. If I was in a jam for points, though, do you get 1/2 would have been a good call? Because that's really 2 to the negative 1, and 1/2 -1 would have been a good call. All right. So I'm just going to make an extra point, and it's not going to hurt anything. So if I was, I didn't even ask you to graph it, but if you did graph it, it would look like this. Asymptote is at 0, and it helps you remember to put it in there. 4, 2, 2, 1, and 1/2, -1. And this just really helps to like seal the deal on where this curve is. There we go. You feeling like you're getting these? Okay. Now, what if the whole thing flipped like that? Seems like it'd be way harder. All it is a negative in the right spot. That makes it flip like that. Where would that negative go? Right there. Because that's a vertical reflect. And do you see that this green line reflected up and down like this? I may not have drawn it perfectly, but get the idea that that's a reflect? But the beautiful part is, as long as you don't forget to include this in your answer, your points would have reflected that, because all your points where y equals would have been negative. See, all your y's would have been negative, and you just make this negative, and this one would be positive. And then boom, you would have had the dots in the right spot in the first place. So let's do one like that, because you probably have one like that on your test. Y equals negative. I don't even know. I haven't seen the test, but I would, if I was making the test, I'd put a negative in it, because it's not that hard, and it makes kids think. Let's do this one with a negative. Just tell me 3 points and the asymptote. Lila, can you tell me a point or an asymptote? If I put in 0, what's that give me? Yep. You can abbreviate it if you want. ASY is a pretty good abbreviation for it. And in case you're wondering, like, where is that? That's the asymptote, which is always, like, right here. Unless you move the whole graph to the right. How could you move the whole graph to the right? If I did that, do you get it would have moved it to the right 4? I didn't, but if I had put that minus 4 in there, the whole thing would have moved to the right 4, and then the asymptote would have moved to the right 4. So process that. Again, if I did this, but I thought you said I said if you make this part be 0. See, then 4 would make that 0, and 4 would be the asymptote then, see? All right, but I'm not doing that this time. Just trying to tell you we could do that too. All right, Andy, can you tell me a couple of legit points? Not asymptotes. 3 gives you what? -1 is perfect. And then? 1/3 would work. Nice. Just to remind you that that would come out to 3 to the -1, and then don't forget the negative, so what's the answer? Yep. 2 negatives makes it positive. And then the 9 would have worked. I know some of you are thinking 9, 9, 9. Yeah, 9 would have totally worked. And then that comes out to 2, and then it's -2. Look, I got 3 points on an asymptote. Yay. Got any questions? All right, then let's start your homework. Everybody find the homework for today. It's a worksheet. I'll tell you which ones to do and which ones to skip. We'll do number 1. We'll skip number 2 and 3. We'll do 4. And 6. And 8. I know that was a little weird. Let's make sure I got this right. I said to do 1 and 4 and 6 and 8. You with me? Okay. And then that little review section at the end is supposed to be like super fast. Those, I'm not having you skip any because you're supposed to be able to go like, that one's 3, that one's 1, that one's, oh crap, 1/2, something like that. So my point is, I know they aren't all going to be like instant, but the 9 through 16 are supposed to be super fast, done in your head. If you don't get one, ask me. All right, let's start with number 1. Oh, that one's too easy. Let's skip a few and go to number 4. Number 4 reads y equals log base 2 of x minus 2. And I got an XY chart. And then you know how to graph, so the hard part's finding the points. Eric B., can you tell me something smart to put in to the x here and here? 0 works, except you're going to realize that you now have log base 2 of -2, and that's not legal. And it's not the asymptote. So it's good to try it, but it didn't really give you anything. Who knows what the asymptote would be? 2 is correct. You want this inside part to become 0. So 2 gives you the asymptote. Sage, you give me another smart thing to put in. Don't say 3.
4.
All right. 4.
It'll be 1.
And that becomes 2. Log base 2 of 2 is 1. Yep, I put in a 4. I got 1. Now, I said don't say 3 just because I thought that would be too easy. But 4 was pretty easy, too. 3 is a good one, actually. Everybody take a second. Don't say it, anybody. Just try to figure out what you get when you put in 3. Did you realize you won the argument and you got nothing? 3 comes 0. All right. Nordstrom, can you tell me another thing I can put in? I kind of run out of easy ones.
You could put in 1/2.
I could make this whole thing be 1/2, but don't put in x as a half. Okay, so pick something else.
Put in a 1.
I can put in a 1, but then I'd end up with log base 2 of a negative. I don't want that. Hint, go with a bigger number.
What about 6?
All right. So let's put in 6 right here where the x is. Let's put in a 6, and then a 6 minus 2 is 4. That works nice. I put in a 6. What do you think I get?
And then you get
It'll be log base 2 of 4. So
4. Oh, no.
this could be thought of as 2 squared. Does that help?
Oh, yeah, you get 2.
2. I got 3 points. I got the asymptote. As long as you can graph those, you got it. So this is all about picking strategic things to stick in. We tried a bunch of numbers that didn't work right. That's going to happen to you also. All right. So the next one we have is number 6. I just want to get you maybe 1 or 2 points on number 6. So everybody look at number 6, please. Stop looking at the other one. Go to number 6. It's all about picking strategic points. 0 is an easy number to put in, so you ask yourself, did that make the inside thing be 0? 1/3 of 0, isn't that 0 still? So that's the asymptote. Yep, it made the inside 0. Now, what's the next number I would normally put in is 1, and I don't want to do... Wait a minute. Would 1 actually work? Yeah, 1 actually would work. You got to try them to know for sure. I put a 1 in, and I go, oh, it's 1/3, and I know that one. Because this is really like 3 to the negative 1. So it's negative 1. Positive. Oh, wait, you're right. I forgot the negative at the end. It's going to come back to positive 1. Good catch. Did anybody else notice that? It was so easy to forget that 1 in front, or that negative in front. Brings it back to positive 1. All right, now I got to try another number like 2. 2 doesn't work. It's gross. Don't use 2. 3? Would 3 work? Yeah, because then you get a 1 in the argument spot, and that's one you're supposed to memorize. All right, I think you got the idea. Pick numbers that work well. Choose wisely. And that's all I got for you for today.